Welcome to lesson 7.4. Today we're going to learn about the areas of polygons. Yes, polygons, the many-sided shapes, poly means many, that are closed and comprised of straight lines. That's a polygon. And squares are polygons, and rectangles are, and octagons, and just about any shape we would deal with, as long as they have straight sides and they have an inside and outside. In other words, they're closed figures. Let's get on with it. All right, for this first problem, we are going to decompose, that means break down, a figure into known shapes so that we can calculate the area of this thing that we don't have a formula for. And what we're looking for, again, are triangles and rectangles, perhaps parallelograms, but primarily rectangles and triangles. And if I look at this, I do, in fact, see two triangles and a rectangle. And two of those two triangles are congruent. They both have a base of 6 meters and they have a height of 2 meters. So I'm just going to call that shape A. Both of them are the same, and then the rectangle is different. And I'm going to start out, of course, with my formula. The area of shape A is 1/2 base height. I'm writing this formula every single time because that's going to tattoo it to my brain so I never forget and I don't make mistakes later on. I'm going to substitute in 1/2 6 times 2. I didn't put the units. I will put the units there in the end, but sometimes when we get more complicated figures, it helps with the clutter. They are all meters in this problem, though, so I don't have to worry about converting units or anything like that. And anyway, when I multiply this, half of 2 is 1, and 1 times 6 is 6 meters squared. For shape B, the area of shape B, that's a rectangle, so that's base times height. And that's going to be 6 meters times 4 meters, which is 24 meters squared. And now I need to combine everything. So for my total area, when I recompose it, put it right back together, I need two area A's, and I need an area B. So I need 2 times 6 plus 24, which is 12, plus 24, which is 36 square meters, or meters squared. Circling my final answer to indicate it to my teacher so there's no confusion, and that's all there is to it. I organized this very carefully and specifically. Everything's labeled. The shapes are labeled on my drawing. The formulas are labeled so I know which formula goes with which shape. Everything's laid out there, and you need to do that too. Stay organized and you will do well in this unit. Now, as an aside, some of you might be noticing that, wow, I took half, for the triangles, I took half of base times height, and then later on, I multiplied by 2. So isn't that just, why divide by 2 and multiply by 2? Why not just not divide in the first place? And that's a good observation. I actually can create a new composite shape by decomposing this and recomposing it differently before I do my calculating. Let's look how I would do that. So what I did is I just kind of went over and outlined and highlighted the triangle on the left, and I actually broke it into two triangles. Now what if I move those over here? That one goes there, right? And this one could be moved over here. And now look what I have. Now I just have a rectangle. So I can just find base times height. My rectangle is going to have this dimension here, and that's going to be 4 plus the height is 2 is going to be 6, and this here is going to be 6, and 6 times 6 is 36. Well, that's what's going on the problem below. Let's look at that. Here they have cut off the two triangles that were over here, right? They cut those off and they put them in those two spots. And so they found out they have a rectangle area equals base times height equals 6 meters times 6 meters is 36 meters squared, which of course is the same as I got above. Here's one for you to try. You have a composite figure, it's a patio I suppose, made up of 3 rectangles, and we want to find the area of the entire shape. In other words, all 3 of those put together. So, looking at this, I have this shape, I have this shape, and this shape looks the same as the first one. So go ahead and calculate the area of that, just as it is. Find the area of the individual shapes and then add them up. And then I want you to analyze that same figure and see if you can decompose and recompose it a little differently so that you can do it with one formula. My hint to you is look for how you can put that together to make a rectangle, and that's for this problem down here. Okay, so there's 2 for you to do. Well, here's another kind of problem. I have this green space in the middle, and it's paved all the way around it, and I want to find the area of the path, the paved path. And I suppose I could like break this up into rectangles like this, and maybe this one, and do all that calculating. But there is a slightly easier way. We could subtract the middle. It's kind of like a donut, right? So we have the outer shape, I'll call that shape A. We have the inner shape, that's shape B. And I can look at this as, I'm going to find the area of A, base times height, I wrote the formula, 7 times 8, which is 56 meters squared. And then I have the area of shape B, base times height, 4 times 3, it's 12 meters squared, and the area that's paved is going to be the difference, right? I'm going to take this whole rectangle, and then I'm going to subtract this little one out from the center. That's the hole in the donut. So I need area, the area total is the area of A minus the area of B, which is 56 minus 12, which is 44 meters squared. Circle my answer. And that's all there is to it. Now this is the third kind of problem they might give you. They're going to give you a shape on a coordinate plane. Sometimes they'll draw it like they did on this one. Sometimes they'll give you the coordinates of the vertices, and you'll have to draw those on your graph and then connect the dots. But they did this one for you. And I need to look at this and decide how to decompose it. There's lots of ways I can do that, okay? I have choices here. So I'm just going to go ahead and draw this line to make a rectangle A. And then I'm going to draw this line here to make a triangle B. And then I have rectangle C there. And I just need to plug forward like I did before, except for I have to count units, right? So if I look at my scale, I see that one box is 1 unit. So I could just count units and know how long sides are. So this one side is 9 units. That's counting. I also could take 11 and subtract 2, right, to give me that side length of 9. This looks here like 6. Okay. This looks like 4 for my triangle right there. And this looks like 5 for my triangle. And that's also 5 for rectangle C. And rectangle C, my goodness, it looks like a square because it's 5 that direction too. Okay, there it is for area shape A. 6 times 9 is 54 meters squared. I know it's meters squared because they told me everything was in square meters. And there's my triangle. And there's my last square. And now I just need to add them up. 4 plus 0 plus 5 is 9. 5 plus 1 is 6 plus 2 is 8. And I get 89 meters squared. That's my answer. So I'm going to circle it so my teacher knows what my answer is. Again, I labeled my graph, right? I labeled it. I wrote formulas. I substituted in. Everything's lined up so I could add easily at the end. It's not all over the place. Organized, neat, and that makes it much easier to get the right answer. Here's one for you to try. This looks like we're going to find, we have another donut, but the donut's pushed over to the side. So I need to know the area of a parallelogram. Well, we did that way back earlier in an earlier lesson. And I have two of them, and I subtract one from the other. So give that a try. We'll talk about it in class. And we have some straight up practice here. Now the only difference between this and some earlier shapes is that they gave you the coordinates and you've got to plot them. Remember? What's up? What's up? Right? Sideways, up and down. So that's how you plot these. So 6 sideways, up 2. And there's that first point right there. So go ahead, calculate that. Find the area after you plot it. So you're going to plot all the points, connect the dots, and then find the area of the inside of that polygon. All right, enjoy.